Okay, so today we're going to take a look at the law of sines and cosines, or the laws of sines and cosines, and more importantly, how to decide which one to use if we're not specifically told which one we're supposed to be using. So just a quick reminder here, the law of sines is that the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side in a triangle. That is really the key to using the law of sines. You have to have an angle and its opposite side. You have to have at least one pair in order to use the law of sines. Now, the law of cosines is a little bit more complicated, and we'd rather not use it if we don't have to, but sometimes there's just no way around it. So, the law of cosines is c squared equals a squared plus b squared minus 2ab times the cosine of c. And if you remember, that's just an alteration of the Pythagorean theorem. We're adjusting it to work in any triangle. So, the law of cosines will work when we have either all three sides, A, B, and C, and we're solving for an angle, or if we have two sides and the angle in between them. So let's take a look at a couple of triangles and see which of those laws we could use. So our first example is going to be this triangle here. So we have a 97-degree angle, a side of 4, a side of 5, and we're trying to find x. So this is that SAS condition. So we know this triangle can be solved. It's just a matter of which of the laws we can use. And the thing we're always going to try to look for is, do we know a pair, an angle and a side that's opposite of each other? Because as long as we know that, we're going to use the law of sines. We don't really want to use the law of cosines unless we have to. So let's take a look. I have one angle here, but I'm trying to find its opposite side, so that's not going to work as a pair. I know this side, but unfortunately I don't know the opposite angle. And I know this side, but again I don't know the opposite angle. So in this case, because we don't know an opposite pair of an angle and a side, we can't use the law of sines. It's not going to work to solve this problem. If we tried, we simply have too many variables to solve. So in this case, we have to use the law of cosines. We have to use c squared equals a squared plus b squared minus 2ab cosine of c. Now remember, just like in the law of sines, the angle c and the side c have to be opposite of each other, but usually we're solving for one of those, or we always are solving for one of those. So in this case, since we're solving for this side x, that has to be our c. And then the angle here has to be our angle c. The other two sides, the 4 and the 5, don't actually matter, because when we add them together or we multiply them together, it's not going to change anything. So we could just call this one A and this one B. It's kind of like in the Pythagorean theorem. They don't actually matter which one's which. C is the important one. So let's take a look at solving this right now. We're going to go ahead and plug in our numbers. I'll plug in x since we're actually saying we're solving for x here. So we've got x squared equals A is 4, B is 5, minus 2 times 4 times 5 times the cosine of 97 degrees. Now, this expression right here is something we can type straight into our calculator, no problem. We don't even need to solve because we have our x over here. We'll just need to deal with this squared at the end. So I'm going to type that whole expression straight into my calculator. And I'll show you what that looks like, typing it all in at once. Slide that up so you can see it. So I'm just going to type in 4 squared plus 5 squared minus 2, and then use parentheses just like I did when I wrote it down. 2 times 4 times 5 times the cosine of 97, and close that last parenthesis. That's going to tell me right there that x squared is equal to 45.87. Now we're not done yet. We still have to actually take the square root of both sides. So we're going to take the square root of both sides of that to get x, and we'll just use the square root function on our calculator and plug in the previous answer, and we get our x is 6.8 if we round. So on this case, using the law of cosines wasn't that bad. We would rather have not. It's a little bit harder than using the law of sines, but we had to use it because we didn't have that opposite pair. Let's take a look at another example now, and we'll see which one we should use. So on this example, you'll see we have two angles. We have the side 15, and let's just say we're solving for that side right there. Now in this one, you ask yourself the question, do we know an angle and its opposite side? And if we do, then we can use the law of sines. And remember, we'd rather use the law of sines if we can. So we take a look. Well, here we have a 68-degree angle, and right across from it, we have a 15 length side. So in this case, there's no reason to use the law of cosines when we could just use the law of sines. And actually, this example is the example I gave in the last video on the law of sines. So if you want to go over that one, take a look back and check out how that's done. Now the last example, I haven't written this one out yet, but the last example I want to do, what if we knew all three sides? Could we solve that triangle? So what if I knew that this was 13, that was 7, and that was 8? Which could I use to say solve for that side, or that angle right there? And again, ask yourself the question, do I know a pair of an angle and its opposite side? Well, I don't know any angles in this case, so the answer to that one is pretty simply no. I can't use the law of sines. So on this one, I am again stuck with using the law of cosines. And again, I'll write that out. And always, always, always remember, the only thing you can solve for in this equation is either angle C or side C. In this case, that means that x has to be angle C. So I'll go ahead and put that down. That's going to be angle C, that's going to be side C, but these don't matter. A and B could be either way. They don't really matter in this problem. So we go ahead and start plugging things in. Little c is your side, so that's going to be 8 squared equals a is 7, so 7 squared, plus 13 squared minus 2 times 7 times 13 times the cosine of x. We're plugging in x for the angle C. Now in this case, we don't know the angle, so we're going to have to use the inverse cosine to